Nishan Saurabh. Right. So the question here is, a coil of metal wire is kept stationary in a non-uniform magnetic field. An EMF is induced in the coil. Sir, is the statement true? According to me, it should be true. But in Arhant, PYQ. What is a PYQ? Solution, they gave both true and false. As the answers, they talk about some time point of view, which I couldn't understand. Right. So what is happening here? Suppose there is a coil. Okay. Let us take this as a loop. Magnetic field is this way. This is a fixed loop. But field is not constant. Suppose this is the x coordinate. So if I write magnetic field B is B naught x, that means as you go along x, B is changing. Am I right? Is magnetic field constant or changing? Non-uniform or uniform? Nishan Saurav, is magnetic field uniform or non-uniform? Non-uniform, right? But is it changing with respect to time? No. So if I say flux, what you do? Integral B naught x dx into L. If this length is L at a distance x, I will take dx. What is the area of this dx into L? Field is B naught x. Integrate from 0 to L. If suppose the length is 0 to L, integrate from 0 to L. This is the flux. But for EMF, you have to do minus d phi by dt. I'll get 0, no. Though B is non-uniform, but this non-uniformity is with respect to x, not with respect to time. Agreed? There is another case scenario where I can say B is equal to B naught x t. So this is variable with respect to x and t. So non-uniform with respect to, but here when you differentiate, you get EMF. So integral 0 to L B naught x dx into t into L. So B naught LT comes out, x dx integral is L square by 2. Am I right? So it is B naught L cube by 2. B naught units will take care of this L cube. It should have been L square, but B naught is Tesla per meter. So the dimensionality is right. So into T. This is the flux. When you differentiate, you'll get B naught L cube by 2. Right. So in the first case scenario, with respect to time, it is constant. That is the meaning of with respect to. Right. I hope you answered your question. Srivatsan, Rishva, Jasmine. Okay. So let us do a new topic today. So we left at wave optics, then EM waves, and then modern physics. So wave optics, let us do the question. To demonstrate the phenomenon of interference, we require sources relation of what, guys? Relation of sorry guys, I have been trying to explain. So here we have a phase difference We should have a same wavelength. That means frequency. So question number 1, we should have same frequency. And phi, delta phi should be constant. The difference between sources S1, S2, right? The difference should be say constant. If that is not constant, what will happen to the fringe? Can I see fringes on the screen? What will happen if the phase difference is not constant? What happens? What happens when the phase difference is not constant? So when phase difference is not constant, the complete screen will be bright. Like it happens in your house, if you are switching on 2 bulbs, what is happening? Will you see fringes on your wall? No, you see a brighter wall, right? So when delta phi is not constant changing, we have bright screen. But when delta phi is constant, we see the fringe pattern. Bright, dark, bright, dark, you remember, no? So this fringe pattern we see. Clear? So option D. The maximum number of possible interference maxima for slit separation equal to twice the wavelength in Young's double slit experiment is. So what is trying to tell? We have two fringe S1, S2 no sources. The slip separation equal to twice the lambda. So what is the distance? 2 lambda. That is what is saying. So when you have a screen like this, when you go to this infinity here, this goes this way, this goes this way. So what is the delta y here? 2 lambda. If you go down, delta y is again, so the ray go like this, one ray go from this, the difference is again 2 lambda. Am I right or not? If someone asks you what is the minimum path difference, that is exactly at the center of screen, how much? Delta x is equal to 0. At infinity, what is delta x? At infinity, delta x is equal to the d gap, and here delta x is equal to minus d. That means if you a minus b, if you do, when you're going up, b travels more than a. When you're going down, a has to travel more. Are you able to understand question number 2? So totally, how many will be there? So here 2 lambda at infinity, here it is 0, so somewhere here lambda. So again 2 lambda at infinity, somewhere here lambda. How many maximas will be there? Central maxima, first maxima, second maxima. So again first maxima is total 5. I am giving you the reason, not just the formula. Why 5 are there? If this is 2 lambda, at infinity path difference will be 2 lambda. At infinity path difference will be 2 lambda. So infinity is 2 maximas. Somewhere from central maxima to infinity 1 lambda. So total ऊपर 2, नीचे 2 and center में 1. So Akshini 5 and Nishant Saurav 5, right? Both are right. So 5 is the answer. But how many you can see on the screen? These are like 5 maximas are formed. Possible. These are possible. But how many you can see on the screen? What about this lambda and lambda? 3. Central maxima, this lambda, this lambda. Total how many? 3. Yeah. So total maximas possible is equal to 5. Total maximas on screen is equal to 3. Because we don't have infinite screens. Screen is a limited length, no? So we have 3. So just the question changes the answer. You understood? So you might be right, but what is asking is not what you are trying to say. So go through the question and try to answer. Okay. Third one. The angle of incidence at which reflected light is totally polarized for reflection from air to glass. So third one, we have of Brewster's angle. So this is glass. I mean glass here. This is not mirror. This is air. So what is saying? The reflected light is completely polarized, I and R. So if you remember this, for Brewster's angle, tan theta is equal to mu, where theta is angle of incidence. S. So what is angle of incidence? Tan inverse mu. Very easy question, basic question. The question remains when I was in school, 10th class, 2004, I was in 10th class. I don't know where you guys were. Fourth one. A Young's double slit experiment uses a monochromatic source. The shape of the interference fringes formed on the screen. At the center, near to the center line, they are straight lines. But basically, if you see, they are like hyperbolas when you go far. In your textbooks, you can see when it is near, they are straight lines. When you go far, they kind of bend like this. If you remember, you can see in the textbook. Right? Next, do in straight lines. Huh? Fifth one. Fifth one, read the question. If I naught is the intensity of the principal maxima in the single slit diffraction pattern, then what will be its intensity when the slit width is doubled? Slit width is double. So now fourth one, should we put straight lines or hyperbolas? But these are part of hyperbolas, no? Am I not right? Though it looks straight line, as you go far, aren't they hyperbolas? I guess it should be hyperbola. What did he give? Yeah, but though he gave I would go for hyperbola. Just Google. So because at the ends they are hyperbolas. That means even these are hyperbolas, but we see them straight. Am I right? Yeah. Latika Srinivasan, hyperbola. Thanks, Ma. So this one, fifth one. If I naught is the intensity of the principal maximum in the single slit diffraction pattern, then what will be its intensity when the slit width is doubled? The size of the slit is doubled. 2I naught or 4I naught. So basically, so what we are doing, suppose there are two slits like this, S1, S2. Gap, if gap is doubled, intensity of this will be doubled now. So initially, let them be I and I. So what is the resultant we got? I naught. So what is I naught? 4I know, because for this amplitude is A. A is proportional to root I. Amplitude of this is proportional to root I. So what we get is 2A. So when you do is amplitude, it is 2A. So when you square it, it is 4A square. So it is 4I. Agreed. So what are we doing now? We are doubling it. So the intensity of each slit, when you are making it double, what is intensity? 2I. 2I. Agreed. So A is becoming A root 2. A root 2. So what is the amplitude here? 2 root 2A. 2 root 2A. So what is 2 root 2A if I square it? 4 twos are 8A square or 8I naught. Sorry, 8I or 2I naught. Am I right? 8I or 2I naught. All right, 2I naught. Amplitude has become a root 2, a root 2. So when it has become a root 2, it has become 2 root 2a. So square it, 8a square. 8a is nothing but 2I naught. What did he give? If he gave a, how come is it a? So the single slit experiment I thought. This is not double slit. Wrong. He's saying single slit. For a single slit, this is not which is happening. For a single slit, we have I, if this is I naught, so then I as a function of phi. So at any point, you have a point where this angle is phi. So intensity at this point, I is equal to I naught into sine phi by phi whole square. There's one formula. That is why we get this curves like this. If you remember the pattern, it decreases like this. Intensity. Remember this? So here, this only depends on the phi value. There is no size of this. Agreed? So I naught is still I naught. Okay, so option 1. Sixth one, when an unpolarized light of intensity I naught is incident on polarized sheet, the intensity of light which does not get transmitted. So unpolarized, how much will come out, guys? I naught by 2. So this is sixth one. When an unpolarized light, so it is like in all directions, right? It falls on a polaroid, we get a single direction, right? This is the pass axis. So intensity of this is I naught. I naught by 2 will come. So how much is left stopped here? I naught by 2 is stopped. Is that making sense? Yes. Everyone, can you understand? So the seventh one is based on resolution power, I guess. 2-point white dots. So we have one on polarization, few on this YDSC and single slit. Remember this formula, you have to remember. 2-point white dots are 1 mm apart. So I cannot draw white here. So I'm taking black dots. The distance between them is 1 mm on a black paper. So it is just reverse of whatever we are doing now. They're viewed by an eye pupil diameter. So eye pupil diameter is how much? 3 mm approximately. What is the maximum distance at which these dots can be resolved by the eye? So how far the eye can be so that you can resolve it as 2 maximum. So if you're more than 5, you see them as a single. So take lambda of white light is 500 nano. Are you able to understand? So if you are at a distance x, when you are very near, you can see them as 2 different dots. After some distance x, you cannot see them as 2 dots. You see them as single dot. Which one, Ganesh Singh? Which question you're asking me to repeat? Sixth or seventh? Sixth one. There is unpolarized light of intensity I naught. There is something called Polaroid. Even in chemistry, we have this Polaroid. There's something called pass axis. So polarizer only sends half of what you send in this. If unpolarized light goes, unpolarized, polarized, half comes out. So half is filtered by it. Okay. Question number 7. There are 2 white dots. Distance between them is how much? 1 mm. Pupil diameter is 3 mm. What is the maximum distance you can see? If you see that is wrong, you can even say these are 2 white dots. You are somewhere here. The islands is here. So what is this x? So that you can still say there are 2 dots. Okay. So here we have this formula, resolution power or limit is 1.22 lambda by d. Right. So this is nothing but this y by this d. So if this is some y, if I say y by x, okay, distance between the points is y, this I took as x, so y by x. Now rest all he gave. So what is that x value? X is equal to y into d by 1.22 lambda. Remember this formula, guys. So basically, you understood this. This is the angle subtended at this point due to this. That is what matters for us basically. So y is the distance, which is 1 mm, 10 power minus 3. Small d is 3 mm. 3 mm means 3 into 10 power minus 3 by 1.22 into lambda is 500 nanometers. 5 into 10 power minus 7, right? 3 by 6 approximately into 10 power. This 7 goes to the numerator plus 7. So 6, 10. 3 by 6 into 10. So 0.5 into 10. So 5. So approximately 5 meters. Are you able to understand this question? That means from 0 to 5 meters, you can say, if I call you and say, you will say, sir, there are 2 dots. If you stand more than 5 meters, it looks like a single dot to you, single point to you. You can actually try it. You can actually try, like take a small pencil, you take a scale on the wall, make 2 points, maybe some white or sketch pen, go with red color. Red lambda will be more, so x will be less. If lambda is less, x will be more. So draw it. Just put 2 dots on the wall. Try to go away from the wall and see. When you are, that means when there are 2 dots, white dots in a black wall, till 5 meters, you can see them as 2 dots. As you go further, you see them as a single dot. That is the meaning of it. Clear? Eighth one, in a Young's double slit experiment, the intensity at a point where the path difference is lambda by 6 is I. If I naught denotes the maximum intensity. So, eighth question, lambda by 6. How to do this? If path difference is lambda, what is the phase difference? 2 pi. Path difference is pi by 6. What is the phase difference? 2 pi by 6 or pi by 3. Agreed? So what is the A resultant? For a maximum intensity is I naught, no? Right? Maximum intensity is I naught. So when does it happen? I naught is equal to, let the intensity of each source S1, S2 is I. I naught square is I1 square plus I2, both are equal, no? Plus 2 I1, I2. So I1 into I2 is again I square into cos 0. This is the maximum, no? So how much we are getting? 4I square. I naught square is 4I square. Am I right? Not I naught square, it is just I naught. It is A square basically. I naught is A square. So this is A naught square, this is A square. This is 4I. I naught is 4I. What will happen if that is pi by 3? So I dash is I plus 2I into cos 60. How much is it cos 60? 1 by 2. So this and this cancel. So it is 3I. I is how much? I naught is 4I. So what is I? I naught by 4. I naught by 4. 3 by 4 I naught. How many of you understood this? 3 I naught by 4. I can repeat. So, Nishant, what about others? I want answers. Yes or no? I won't be asking you questions, so don't worry. Yes or no? Great, guys. Yes, got it, sir. Is it me who underlined this? No. So this is done. Next, EM waves. So that is wave optics. This is wave. Let us write it here. It's some little different color. What is next? EM waves. So electromagnetic waves, if you remember, I'm just giving an idea of what is electromagnetic wave. So they are produced by different sources like sunlight, light, not just light, radio waves. Radios produce EM waves. All electronic devices produce EM waves. We are not producing any radio waves, but our body produces infrared rays, heat waves. They are again EM waves. So electromagnet, even we people produce electromagnet like this, right? So one is magnetic, other is electric field. So they support each other. Due to magnetic, we get electric. Due to electric, we get magnetic. So speed of this is how much? C. Speed of this is C. These are like very basic questions. So infrared rays, radiation is detected by photometer, nanometer, spectrometer, pyrometer. Electromagnetic wave are transverse in nature is evident by polarization, interference, diffraction, reflection. So polarization gives Earth the oscillations are normal, right? That is what we are giving a polarized and we are getting a polarized light. So it is giving you that it is transverse in nature. Agreed or not? Diffraction interference says they are waves. Diffraction interference says they are waves. Reflection says they are particle nature. But what about transverse wave? They could have been longitudinal wave. No. So transverse nature of the light wave. So transverse nature is shown by polarization. Wave nature. So wave nature is shown by diffraction and interference. Particle nature is shown by reflection. You understood? Like ball hitting a wall, particle nature, reflection. Hope you understood. Which of the following are not electromagnetic waves? Cosmic rays, gamma rays, beta rays, X-rays. Right. Beta are electrons, right? Cosmic rays are EM waves. They are very high energetic. So beta rays, electrons. So they are not EM waves. Consider telecommunication through optical fiber. Which of the following statement is not true? Optical fibers can be of graded refractive index. Not true. Huh? Optical fibers subject to electromagnetic interference from outside. Optical fibers have extremely low transmission loss. That is right. Optical fibers may have homogeneous core. That is all with a suitable cladding. Right. So odd one out and wrong is subjected to electromagnetic interference. We have telephone lines which are like copper wires. They have this interference. Disturbance. When you're talking to someone, you say disturbance and all. The optical fiber doesn't have that disturbance and all. Because that is made of plastic material, it doesn't get induced much by the outside disturbances. Hope this is clear. Next one. An electromagnetic wave of frequency 3 megahertz passing through vacuum into a dielectric medium with permittivity epsilon is 4. Then wavelength is doubled, the frequency remains unchanged. Then wavelength is doubled and frequency becomes half. Wavelength is half, then frequency. So first we have to find out the mu value, refractive index. Once you know the refractive index is done. Epsilon r is 4, right? So mu refractive index is how much? Under root epsilon r into mu r, if you remember. So mu r is not given, which is 1. Epsilon r is how much? 4. So it is how much? 2. You remember this? Refractive index mu. Basically, refractive index is speed of light in air by speed of light in medium. Medium is V. So C is how much? 1 by root mu naught epsilon naught. And V is 1 by root epsilon r mu naught mu r into epsilon naught and mu naught. So these two gets cancelled. What we get is under root mu r epsilon r. Remember this. Refractive index mu or n is equal to under root mu r and mu relative, epsilon relative. So we got it as 2. Here he only gave mu this. If there is also mu relative, substitute that also. So 4. So we got mu as 2. So frequency remains same. No, frequency won't change. So option A, frequency is unchanged. Option C, D. So what will happen to the speed? Speed becomes half. Agreed? That means wavelength is halved. Wavelength is halved and frequency remains unchanged. Am I right? Yes. Good. So how to use the formula and all you understood? Sixth one. Because this chapter is easy, guys, you can do questions from this and wave optics for sure. They're small and easy to clear. Next, sixth one. The RMS value of electric field of light coming from the sun is 720 Newton per Coulomb. So RMS electric field, that is ERMS, 720 Newton per Coulomb. The average total energy density of electromagnetic wave is. Do you know this average value? So basically, energy is energy due to electric field plus energy due to magnetic field, and both are equal. You know this? Both are equal. So average energy due to electric field is half epsilon naught E RMS square, and average energy due to magnetic field is 1 by 2 mu naught. Here epsilon in the numerator, this is in the denominator, and B RMS square. This is magnetic field RMS. Luckily, these two are equal. So though he didn't mention B RMS, you can still find it out. C is equal to E RMS by B RMS or E naught by B naught. You can substitute again here, or I can see the say it is 2 times. These two are equal, no? These two are equal. So I will replace this by this. Instead of finding out B, I'll save my time. So 2 times half epsilon naught E RMS square. Are you able to understand this? Agreed? So it is epsilon naught 8.85 into 10 power minus 12 into this ERMS is 720 square, right? So it is 7.2, 7 sevens are 49, approximately 50 I can put, right? So this is 7.2 square is 550 into, if I take 100 common here, so 10 power 4, 8.85. I'm just telling you how to approximate. 7 sevens are 49, I know. So I'm just approximate, I'm not doing the exact thing. So that I'll save time because we have multiple options. I can see the nearest value. You can see they are different 3.3, 4.8, 6.3 like that. So 4.4 approximately, 44. This is 44 into 10 power minus 8 or 4.4 into 10 power minus 7. So am I right? Minus 7 or did I do? Did I miss here 720? Means 10 power 4, 10 power 4, 10 power minus 8. Ten power minus 6 here. Oh, another 0 is there. This is 10 power 5. Because 7 square is 50 we are putting, no? So 10 power minus 6. Yeah. So option B is near, no. I just saved time by approximation. So when do you exactly see? Few people try to solve everything to the extent it is right to fourth decimal. When you should do when the options are very near. When the options are far, why you want to waste time on this exact calculation? Round it off somewhere near to it. I would have taken 8.8 as 9. 9 5s are 45. 4.5. It is much easier, no? You understood? So that simplification is what matters. That is where we save time, guys. So EM waves is done, right? This is atomic physics, basically. So we have atomic physics here. Are you able to understand? Right. So in atomic physics, we have this photoelectric effect questions. Sodium and copper have work function of 2.3 eV. So sodium's work function. And the ratio of wavelength is nearest to. What is the ratio of wavelength, guys? That is lambda. So work function is Hc by lambda of sodium. No. So lambda is proportional to 1 by work function. So lambda of sodium by lambda of copper is phi of copper by phi of sodium. So 4.5 by 2.3. Am I right? Approximately 2 by 1. So 1 is to 2 or 2 is to 1? 2 is to 1. Right, guys? Able to understand? work function and relation with that threshold wavelength. So two identical photocathodes, that means there is a material. So work function is 5. Two identical, so both are work functions 5. Frequency F1, frequency F2. The velocities of the photoelectrons are whichever electrons coming out is V1, electron coming out is V2. So what is the formula here? H nu is the energy incident, is work function plus energy half m V1 square. And for this, HF2 is work function plus half m V2 square. Am I right? Same material, similar materials, so work function is same. So they're asking the relation of V1 square minus V2 square and also subtract that. So we have V1 square, V2. So V1 minus V2. So do the difference. Half m into V1 square minus V2 square is equal to H into F1 minus F2. Right? So V1 square minus V2 square is 2H by m into F1 minus F2. Option A. Are you able to understand this? Question number 2. Others, you have your chat box. Just say yes or no. Nothing more, nothing less. Your S means a lot for us, an encouragement, okay, that you are still awake and listening to the class. Right. Let us do this question. Fourth one. The work function of a substance is 4 eV. Work function is 4 eV. Okay. The longest wavelength of light that can cause the photoelectric. So again, 4 eV is equal to hc by lambda, but it is in terms of energy eV, man. You have to convert it. So how much is it in terms of joule? 4 into 1.602, that is I'm neglecting, 10 per minus 19 joules is hc by lambda. hc by lambda 6.63. I'll write 6.6, 10 per minus 34. 3 into 10 per 8 by lambda. Lambda is how much? Which we have to find. This is how we should approximate, guys. So lambda is 6.6 into 3 by 4 into 1.6. How much is it? So see that you can, instead of writing the next step, no, we can actually multiply and write. Sometimes we can cancel or sometimes you can multiply. Your job, your interest. So you can either calculate. Yeah, you can remember that also. If you remember the shortcut, that is well and good. If you don't, this is how we solve. It says 1240 EV nanometer. Okay, so you'll get lambda in terms of nanometer. Right. Who is that rounding off it again? 18, 18, 119.8, 24, 4, 6.4 into 10 power 19 plus 8. How much? 27. So 4 plus 3, 7. Agreed? So 6 threes are 18. So approximately 3. So what are the options? 540, 440, 310. Yeah, 300. Approximately 300. I'm going for this. Yeah, our friend was suggesting HC value is how much? 1240 EV nanometer. If you remember, yeah. So instead of HC by lambda, which is energy E, lambda is HC by E. So E you can substitute in terms of EV. So this is 1240 by energy is 4. You'll get in terms of nanometers because EV got cancelled, no? So you get nanometers. 4 threes are 10s are 310. Easy. But you have to remember. If you're remembering, yeah, this is how we save time. So remember this, save time. Your call. This is where coaching, no? People use the coaching part and all. So 310. Approximation also you can do. A charged oil drop is suspended in uniform field of 3 into 10. There's an oil drop, Millikan oil drop experiment. There's an electric field 3 into 10 power 4. If electrons are here, electric field is here this way. So it is being suspended, volt per meter. This is the electric field. Neither false nor this one. Mass of the charge is this and G is this. Charge on the drop will be. Charged oil drops, so it's neither false nor rises. The charge on the drop will be. Take the mass of the charges. It's not mass of the charge, it's mass of the drop. 9.9 into 10 power minus 15. Okay. So it is like mg weight is there and charge, if charge is q, eq is the charge, right? He's asking the charge. So the force eq is equal to mg. Q is equal to mg by e. Mass is how much? 9.9 into 10 power minus 15. This is 10 by e is 3 into 10 power 4. 3.3 times. And this is 4. This is going 10 power minus 3.3 minus 14 and 4, 10 power minus 18. So what is the answer? Option A. They gave 3.3 as well as 3.2, two options, but we got 3.3. I guess 9.8. If you put 9.8, how much do we get? Are we getting 3.2? 10 means that is fine. If I do 9.8, it will be still near to 3.3, I guess. Still it is near to 3.3. Even if I put 9.8, it is still nearer to 3.3. Did you use G equal to 10 he gave, so no issue also. G is equal to 10, so 3.3. Clear? Yeah, but G is given. Right? Which value, man? Option A, 1240. Yeah. Sir, Professor H.C. Verma used this value in one of his video on your YouTube. Which video? Which value? 1240. Yeah, that is given in many textbooks also. Like if you go Cengage and all, they'll give this shortcut 1240. Yeah, so they keep that value. Time save karne ke liye. Next one, sixth one. A photocell is illuminated by a small bright source placed 1 meter away. The same source light is placed half-meter away. The number of electrons entered by the photocathode would. Sixth one. A photocell, there is a photocell. There is a source. This is the source, bulb source. The distance is how much? 1 meter. So intensity, let it the power be P. How much is the intensity? I is equal to, if the radius is R, P by 4 pi R square. Agreed. Now R is 1. Intensity is I. Now when you make R by 2, what will happen to the intensity, guys? So R by 2 square will become 4 times. Agreed or not? So when you are bringing the photocell to R by 2 half meter, I dash will be P by 4 pi into R by 2 square. This 2 square goes up, so 4I. Intensity is becoming 4 times. So it will produce 4. Agreed or not? Option D, Nishant, Saurav, Akshini, right, right, you're right. If the kinetic energy of an electron doubles its de Broglie wavelength, seventh question, what is de Broglie length? Lambda h by mb. So how to put that velocity? Kinetic energy is half mv square. Velocity is how much? Root 2 ke by m. So basically is h by root 2 ke m. Agreed? So this is the lambda. What is saying, if the kinetic energy of free electron doubles, so k is becoming double. So lambda will change by how much? 1 by root 2. Right? So lambda dash is lambda naught by root 2 if ke is doubled. Denominator may I have to write just 2ke, right? 1 by root 2. Option A. It is 1 by root 2 ma. So multiply by 1 by root 2. Next one. The time by a photoelectron to come out after the photon strike is, this is like conceptual value. So it is there in textbook, very small, 10 power minus 10 seconds. The threshold frequency of a metallic surface corresponds to an energy of 6.2 eV, and the stopping potential for the radiation incident on this surface is 5 volt. The incident radiation. So you have to find the energy first. So he said metallic surface correspond to energy. So work function is given as 6.2 eV and stopping potential is 5. So extra energy is how much? So total energy, that is like h nu is equal to work function plus k, work function is 6.2 and eV and kinetic energy is 5 eV. So total is how much? 11.2 eV. So which wave has this region? So ultraviolet, visible region, infrared, X-rays. Which one gets? 11.2 eV. So find out lambda. Lambda in nanometers is how much? 1210 na? By 11.2. How much are we getting? Around 100. Agreed or not? 11 are 121 na? So approximately 110 nanometers ankondi. So it is near in the region of ultraviolet or not? It is, if it is just in Armstrongs, it is how much? Around 1000, 1100 Armstrongs. But it's just in Armstrongs. What happens? 1 Armstrong, 2 Armstrong, it is X-rays, right? But this one is ultraviolet. Is that clear? Any doubts for anyone how to find it out? The anode voltage of the photocell is kept fixed. The wavelength lambda of the light falling on the cathode is gradually changed. Wavelength you are changing. The plate current I of the photocell varies as follows. So what is it? For a high wavelength, it will definitely come as the wavelength decreases. For high wavelength, it doesn't come. So if you see this here, I marked it. This is where it is going to infinity because we have somewhere here threshold. That is where it will start that, so that is lambda naught. That is where the photoelectric effect start. As you further decrease, energy is more, so the intensity will increase. So as you come down like this, as further decrease lambda, intensity should increase. Agreed? Option C. Here lambda 0 is very infinity. This is wrong. This is wrong. Here, as lambda is increasing, intensity increasing. That is wrong. No. As lambda increases, intensity should decrease, basically. Option C. Conceptual question, basically. Photon of frequency nu has a momentum associated with it. If c is the velocity of light, then the momentum is. What is P? H by lambda, no. P is equal to H by lambda. Lambda is C by nu. So nu goes to the numerator. Option A. Lambda is C by nu. So C by nu. It goes to the numerator. So 12th one. If GE and GM are the acceleration due to gravity on the surface of the Earth and the Moon respectively, and if Millikan oil drop experiment could be performed on both the surfaces, one will find the ratio electronic charge on Moon to that of Earth. It will be universal, same, no one. You do the experiment even on Earth or Moon or wherever, it is still the same, right? So that doesn't change anything. This paragraph question. Question 13, 14, 15 are based on the following paragraph. Wave property of electrons implies that they will show diffraction effect. That is the wave nature. Davison and Germer demonstrated this by diffracting electrons from crystals. The law governing the diffraction from a crystal is obtained by requiring that electron waves reflected from the planes of atoms in a crystal interference. So it's like electrons go and hit, multiple layers reflect multiple electrons, right? So the reflected ones get interfered. So the path difference is 2d sine theta. If you remember the path difference, what is delta x, guys? Theta is the angle of incidence. 13th, electrons accelerated by a potential V is diffracted by a crystal. If D is 1 Armstrong, small d is 1 Armstrong, I is 30 degrees. V should be about, he's asking the voltage V. H and mass of electron and E are given. Is it like constructive interference? So if you have to see the constructive pattern, so 2d sine theta is n lambda. He's asking the value of V voltage. So first find out the lambda. So lambda is 2 into d is 10 power minus 10. into sine 30, 1 by 2. What did they give? I is 30 degrees. So, okay, I is 30 degrees. So 2D sine theta. So what is the theta? Is it I or the difference in, I mean, this one? This is D. This is I we have taken now. So this is also coming like this. This is the extra distance. This is I. This is 90 degrees. I'm dropping a normal 90 degrees. Parallel lines normal. So this will be 90 minus I. So this is I. So this is cos I. Am I right? If this is D, this is D cos I. D cos I. Or I can say, yeah, D cos I. So this sine theta, this is this theta. This is the theta. So theta is 90 minus I. Agreed? Theta is how much? 90 minus I. So sine, it is not sine 30. So we have to put lambda is equal to 2 into d is 10 power minus 10 into sine 60. What is sine 60? Is the lambda value. So from lambda, how to get the stopping potential or root V? This is not given. The formula is not given. So root V is 12.27. This is the formula by lambda. This is for electron. Basically, how do we get it? Kinetic energy is EV, no? Kinetic energy is how much? EV, which is half mv square, which is EV. From velocity, you can say this is voltage and this is velocity. So lambda is h by mv, right? So velocity is how much? H by m lambda. Velocity is how much? H by m lambda. Substitute that here. So half m into v square. V square is how much? H square. M square lambda square is EV. Agreed? So 1m got cancelled. So lambda square, right? Lambda is down or up? Yeah. So lambda square is equal to h square by 2m EV. Agreed? From this, lambda means under root h square by 2m EV. This is nothing but under root whatever we got, 12.27 into 10 power minus 10. That is the value I gave by root V. So either you can bring this here and take that there. This is the relation of lambda and V voltage. Is that clear? So in this question, he is asking us the voltage. So root V is how much? 12.27, 10 power minus 10 by, how much is that value? Root 3 we got. Root 3 is 1.73 into 10 power minus 10. This gets cancelled. 12.27 by this, how much are we getting? 17 tens are 8. So approximately 7 I can take. So 1s are 7, 7 7s are 49. Yeah, approximately 7. So V is approximately 49 volts. Right. So we have 50 here. C is 50 volts. Am I making sense, guys? 13th one. So one thing what you should be conscious is I is 30, but this theta is not I. This theta is this grazing angle. Theta is 90 minus I. Be clear about it. That also I derived. I took this D and D, so I found out. I got it. So yeah, so 14th one he gave, I guess. 14th one. If a strong diffraction peak is observed when electrons are incident at I from the normal D. So basically, we should put, instead of sine theta, we should put cos I. We should put cos I. So 2D cos I is n lambda. 2D cos I is n lambda. Basically, sin theta in a flow, people go with sin theta. So sin I, just like option D mark kar denge, but that is wrong. That is sin theta. So sin 90 minus I, which is cos I. This is done. 15th one, in experiment, electrons are made to pass. This is like single slit experiment basically. Instead of light, we are using electrons to show the wave nature of electron. In experiment, electrons are made to pass through the narrow slit of width d comparable to their de Broglie wavelength. They are detected on the screen at distance d from the slit. Which of the following graphs can be explained to represent the number of electrons and detected as a function of the uh, detector? So which one do we have? Is not square, wrong. This curve is wrong. So this should be this curve. But here he has given it is more than D and here equal to D. So basically when they go, they'll bend, right? They'll bend. So we have a curve which is more than D, right? Option A. Yeah, that is what I'm saying. Either A or D. But here he gave is equivalent to D. Exactly, it won't be D. If you remember in this wave optics, YDSC, sorry, single slit experiment. So we should have this more than D. This whatever length is should more than D. Clear, Nishant? Elimination. This is what we call elimination. So no need to do research and all. Now you see how many questions you did. 15 in this. 6. I did 6. Yeah, easy only. 21. And here around out of 8 maybe. All we did that. So you people are doing well actually. So speed got increased. You are able to understand, right, what I'm trying to say. That is electrons and all. So here at atomic physics and nuclear physics got mixed up. Then we have this and semiconductor devices, communication systems. Those two chapters are left out. So shall we start a little from this too, guys? Let me see how many are still there. 33. So around 10 people dropped. Oh, it's already 7:42, no? We did decent questions, guys. So nuclei, we can keep it aside. Atoms, we can do at least few. Just 5-10 minutes, not much. Okay. This nucleus. The specific, okay, atoms and nucleus, nuclei. At a specific instant, emission of radioactive compound is deflected in a magnetic field. The compound can emit electrons, protons, helium is alpha, neutrons. The emission at that instant can be, what is that, guys? Easy guess. Oh, connect charger, 4%. No, so I guess 5 minutes it will take. So neutrons are neutral. They cannot get deflected by magnetic field. So 1, 2, 3. Am I right? 1, 2, 3. If 13.6 eV energy is required to ionize the hydrogen atom, then the energy required to remove electron from n is equal to this one, 2. So it is 13.6 by n square, if you remember. When n is equal to 1, 13.6, n is equal to 2. So 13.6 by 2 square, 4. How much is it? 3.4 eV. So energy required to ionize electron from the second shell. This is the second shell, n is equal to 2. So we need 3.4. Third one, if n naught is the original mass of the substance of half-life period, T half is 5, and the amount of substance left after 15 years is, so this is nuclear, it's okay. Initially n naught, in first 5 years, how many will be there? N naught by 2. Next 5 years, n naught by 4, half. Next 5 years, n naught by 8. So 15 years is 3 T halves. So basically it is n naught by it is 15 by 5, which is 3. This is small n, 2 per n. So n naught by 2 cube, which is n naught by 8. Clear? How many are left out? N naught by 8. How many are gone? 7 n naught by 8 are gone. Which of the following radiations has the least wavelength? Gamma, beta, alpha, X-rays. Beta and alpha are electron and proton. They are particles. They have larger wavelength. Gamma and X-rays are EM waves. They have shorter wavelength. In that, gamma is more energetic, so much shorter wavelength. So if you ask me to arrange the lambda, so again, beta and alpha depends on the velocity. I can say lambda of gamma is smaller than lambda of X is smaller than lambda of beta is less than, sorry, lambda of alpha. Is that clear? Fourth one. Fifth one, good Isha. Uranium 238. Uranium 238 is there. It is getting parted as one alpha. Alpha is how much? 4. And this is 234. Is asking alpha has a speed of u. What is the speed of this v? 234v is 4 into u. 4u by 234, but opposite direction, so minus sign. Minus 4u by 234. Am I right? Conservation of momentum, guys. We have around 31 questions, lot to do. I did 5, so 26 more. So we can do others later. You can actually take screenshot if needed. I will try to post this in the group, this notes and all. You get it in the group. This is 30 questions. We have how many? 26. Next session, we'll complete it. So we have one more session for physics, guys. So we'll complete these 2 chapters. Okay. So in the meantime, your work. So whatever we have done, go through these chapters. We have optics, electromagnetic waves, atoms, nuclei, and atoms and nuclei, photoelectric effect. We can actually do more, right? So if you do it, you'll understand it better.